My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 629. In this lecture, I will continue my discussion on transfer learning. There is a third case that you can do. The third case here is, instead of retraining just the last few layers, you have the model with the VGG16 plus ImageNet. You can use this as an initial model. You can change the whole model. You can tune the complete model using the dataset capital D of Xi's and Yi's. So what are you doing here? You are using the final output that you got on VGG16 plus ImageNet as the initialization for the new model, and you fine tune it. When you fine tune, of course, you keep low learning rate. Just keep small learning rate. Fine tune all the layers. That is important, isn't it? Fine tune all the layers. Fine tuning the whole model here, isn't it? Fine tune all the layers. Fine tuning the whole model here. That's the third option. We will see when to use what option. The first option is don't fine tune anything. What is first option? Don't fine tune anything. Just use CNN codes. Use the ConvNet as feature engineering. Second is just, what is second? Second is just to fine tune last layers. This we already discussed, isn't it? The third option is use VGG16 plus ImageNet as initialization, and then fine tune the complete model using the new data set, isn't it? That's what we discussed. Yes, of course, there is always case 4. What is this case 4? Just ignore the pre-existing models, retrain the network from the scratch, and most people don't do this. This is very expensive because you have somebody who have taken weeks together and some of the advanced GPUs and train the whole model for you. Why dump everything? Because at the end of the day, simple things like edges, simple shapes are still critical for all object recognition tasks, isn't it? So why dump everything? This is something that very few times you end up doing. Let's look at cases when we should do case 1, case 2, case 3, so on. I would argue that you would avoid case 4. I would argue that you would avoid case 4 most of the times. Let's see where the case 1, which is basically using VGGNet as a feature engineering tool. The second case, you are fine tuning the last layer. The third case is you are using VGG16 plus ImageNet as initialization and fine tuning the complete model. And case 4, we are training everything from scratch. So it depends lot on two things. So you have new data set capital D. You have your data set capital D equal to Xi comma Yi for your task. You have the original data set, which is the ImageNet data set on which model was trained, isn't it? VGG16 was on which VGG16 was trained. Which option should you take? That's important. Which option should you take? Case 1, case 2, case 3, case 4 depends on the size of D. It depends on the size of your data set, size of the task data set, I can say. And also it also depends on how first factor is it depends on size of the data set, and second one is how different is your data set with the ImageNet data set. Let's write cases. What is my case 1? Case 1 is if your new data set is very similar to the original data set, which is ImageNet, isn't it? That's what it says. What it says, just time being, just understand this one. If your new data set capital D is very similar to ImageNet, and another one is the size of the D is also small. Yes, what it says, the size of the D is small. First one is your D is similar to ImageNet data set, and second one is the size of the D is small. The size of the the size of the data set is small. You should not worry too much. You just use CNN codes, which is case 1, which means case 1, which means use the model like which model? Use the model like VGG16 as a feature engineering tool, isn't it? In this case, what you have to do, use the model like VGG16 as a feature engineering tool. Feature engineering tool. This we already discussed, isn't it? Okay, if your data set is small, if your data set is small, let's say I just have my maybe 2000 images. Data set is small means what? Let me assume there are 2000 images. I know my cat versus dog data set is very similar to ImageNet, isn't it? ImageNet data set, because ImageNet data set also has lots of images of cats and dogs. Of course, it has images of planes, buses, trucks, etc. Just try to recall, we discussed about this particular data set, but still this data set is very similar. This data set is very similar to the ImageNet. Imagine this data set is completely, imagine this data set is completely different. Imagine my data set is some MRI scan like brain. Let me assume this data set is completely different, as something like MRI scan like brain, like human brains specifically. If the ImageNet data set does not have any brain scans, and your data set has some brain scan data set, that's important here, and you wanted to determine whether there is a tumor in the brain. That is important. Whether you wanted to determine whether there is a tumor in the brain, then your data set is not similar. Your data set is not similar to the ImageNet data set. We will see what to do then. This is case 1, isn't it? So let's look at case 2. What is my case 2? In case 2, let's assume new data set is in case 2 your new data, let's assume new data set is large, but the new data set is very similar to the original data set, which is here in ImageNet data set. Then what you can do here is you can simply fine tune your model. You can simply fine tune your model. We simply fine tune the complete network, isn't it? Why are you fine tuning the complete network and not just last few layers? Because you can simply fine tune the complete network, isn't it? Because this is important point. Why are you fine tuning the complete network and not just the last few layers? Because I have lot of data here. I can fine tune. I can afford to fine tune the network. That is important, isn't it? I can afford to fine tune the network. I can afford to do, because my data set is large. That's why I am fine tuning the whole complete network, not just last few layers, because I have lot of data. Here. I can fine tune. As I have lot of data here, I can fine tune. I can afford to fine tune my network. I can afford to do, because my data set is large. That's why I am fine tuning the whole complete network. And when we do it, when we do it, keep small learning rate. That's important. So we keep small learning rates. This is the option that we can do. Imagine if D is medium size. Just let me say, if your data set is medium size and D is very similar to, your data set is very similar to my ImageNet data set. Let's think of this as case 3. Yes, I will discuss about this case 3 in my next lecture, that is in lecture number 630. Thank you very much.